Now we will solve the third problem. Given u is equal to sine 2x divided by cos h 2y minus cos 2x. I have to find f of z using the Milne's method. So in this case, the function that we are using is little bit complicated. So first what I do is I calculate dou u by dou x. Here the function x appears in the denominator as well as in the numerator. So what I will do is I will use the quotient rule. You will have cos h 2y minus cos 2x the whole squared in the denominator, and in the numerator you will have cos h 2y minus cos 2x, and the differential of this will be sin 2x will be 2 cos 2x minus I will have sin 2x and the differential of cos h 2y will be minus sin x 2y. Already I have a minus sign, so I will have this to be 2 sin 2x. So now what I have to do is I have to substitute x is equal to z and y is equal to 0. So dou u by dou x will be, in the denominator I will have 1 minus cos 2z the whole square. This will be very simple. Y is equal to 0. So e power y plus e power minus y by 2 will become 1. 1 minus cos 2z. And similarly, here when I substitute here y is equal to 1, I will have 1 minus cos 2z, and this will be 2 cos 2z. Okay. And when I substitute this part, I will have minus 2 sin squared 2z. Okay. So now when I simplify this, I will have 2 cos 2z minus 2 cos squared 2z minus 2 sin squared 2z whole divided by 1 minus cos 2z the whole square. Okay. So now what I can do is I can again rewrite this as 2 cos 2z. What I will do is I will remove this 2 outside. I will have cos squared 2z. This will be sin squared 2z whole divided by 1 minus cos 2z the whole square. So dou u by dou x will be 2 cos 2z minus 2 by 1 minus cos 2z the whole square. This I can write it as minus 2 divided by 1 minus cos 2z. This will be dou u by dou x. Okay. And now what will be dou u by dou y? Dou u by dou y. Here I have y only in the denominator. So now what I will do is I will write like this. This will be minus sin 2x divided by, this will be cos h 2y minus cos 2x the whole square, and differential of cos 2y will be 2 sin h 2y. Okay. When I substitute x is equal to z and y is equal to 0, I'll have dou u by dou y. This will be 0 because sin h 2y will give you 0. So dou u by dou x gives you minus 2 by 1 minus cos 2z, and dou u by dou y will give you 0. So in this case, when I substitute this in the formula for f dash of z, I will have f dash of z is equal to dou u by dou x minus I dou u by dou y at z comma 0. Okay. Now what I have to do is I have to substitute this. This will give you minus 2 by 1 minus cos 2z, and this will give you minus 2 divided by 2 sin squared z. 2 gets cancelled here. This gives you minus cosecant squared z. Okay. This we know. What is cos 2z? Cos 2z is equal to 1 minus 2 sin squared z. I have substituted here. This will give you minus cosecant squared z, and from that f of z will be integral of minus cosecant squared z dz, which turns out to be cot z plus c. So in this case, the real part of cos z will be sin 2x by cos h 2y minus cos 2x. This completes the solution of this particular